My name is Eldad Assis. I am an architect at JFrog, and I'll be talking to you a bit about the journey we've done starting in using Kubernetes all the way from initial POC all the way into production and the lessons we've learned from it. So about myself, I said again, I'm an architect at JFrog. I've been doing this pretty much for 15 years, coming and going from the configuration management world, system, and now DevOps infrastructure, platforms, and tools, and some cloud in between. You are welcome to find me on Twitter, on LinkedIn. I'll be more than happy to connect and share and answer any questions. Who here is familiar with Kubernetes? Who uses Kubernetes? Okay, all right. So I hope to give you some insights and easier getting started tricks for you. So I assume you know a bit about Docker. I assume you know a bit about Kubernetes. You don't have to be experts at it. I'm going to share my experience. I'm not going to do any deep diving technical demos. I'm just going to be talking about the things that we've learned going through. There will be some technical terminology. By all means, if you have any questions, come and find me at the JFrog booth right after we're done. So first of all, let's talk about why. Why did we go there? There's no reason to do it if you don't really need it, if it doesn't solve a problem that you have now. And we had several problems. One of the problems is that we wanted to speed up the process of getting a running environment. Not just running a local Artifactory on my laptop, but actually a production-grade Artifactory and sometimes configured with X-Ray or with any of our other products that anyone can spin up quickly, easily, on demand, without the need for any technical knowledge. Just find a button, click it, wait a few minutes, and you get it. We wanted to speed up and improve the CI/CD process per branch. Every developer works on their branch, and they require to take their branch through the whole CI and CD process in order to be able to make sure that before they merge it into our master or to our release branch, that it has passed all of the required tests and quality gates. We wanted to get a better utilization of the resources that we have. Up until then, when you wanted an environment, you had to request a VM. Someone in IT or DevOps would provision a VM for you, and then you'd use this VM like 20% of its resources for just a few hours, and that VM will be running idle for a few days afterwards. One of the most important parts is that we wanted to be big players in the Kubernetes world by providing our applications to install in Kubernetes. If you're familiar with Docker, then you're familiar with this diagram, which means there's a very, very big difference between running your Docker locally and running it in production. Everyone thinks that Docker is the coolest thing, it's the easiest thing. Yeah, you just Docker run it and everything's working. But far from it when it comes to production. Running your containers in production requires a lot more than just the container itself. Let's just skip to the end. So if you need to take back with you some lessons that I've learned, these are the lessons. You need to start small. You need to get the application ready before you go into Kubernetes. Security, you have to be aware of what's running in your cluster, what's running with your application. And you have to limit your application. Application running inside a container or inside Kubernetes can grow and use up much more resources than you really would like to give it. Use the health probes. They're very powerful and very important. Get good visibility of what's going on inside the cluster. Kubernetes is an abstraction layer that actually makes it harder for you to understand what's going on inside. And spread the word. It's a big community. It's growing. There's a lot to learn from it, and there's a lot of great knowledge to be gained. So when I started out looking into it, this is what I thought. I read a few blog posts, I saw a couple of videos, and this is what I felt. This is it. This is the one ring to rule them all. With this, I'll come to my perfect, complete solution. But the reality is more like this. And I will share with you the trip and the lessons I've learned going through this journey. So this is usually how I start adopting a technology. As an architect, I many times look into new technologies. I try and figure out what are they doing there, what value do I gain from it, and is it really useful for solving my problems? So I see it, I look it, I try it, I fail a couple of times, and then I try again. And this is very much my story with Kubernetes. So, okay, where should I start? You should start small. One of the things that I've initially started with, okay, let's just pack up Artifactory in the Docker, let's push it into Kubernetes and let it run. And I will tell you, I was able to crash a GKE Kubernetes cluster in Google Cloud several times myself, turning to Google support, which sent me to go and debug my kernel crashes. Personally, I didn't like it. But yes, that's what happened. Try and find the existing demos. There's a million of them. The official Kubernetes website has wonderful demos and wonderful tutorials to get you through the initial getting started in understanding. When you start using or you start looking into putting your application inside, set a minimal goal. My minimal goal is just to get the container up and running and then coming down. My minimal goal is just to expose a single HTML page that I can go through. My goal is to expose a port that will allow me to monitor the performance of my application. Something very small, very minimal. Get comfortable before you move on. There's great value into using the managed Kubernetes services. The public clouds all offer it. And it really allows you to focus on learning how to prepare to use Kubernetes and not learning Kubernetes itself, which can distract a lot of your time. Most important, start with the application. There's a lot to do before you're ready to go into Kubernetes. It's not just putting it in a Docker container and running it. Logging. If you're familiar with the logging mechanism of Docker, or containers in general, your logs should usually go to standard output, standard error, and then be collected by a log collector. Need to think about what happens when you need to handle multiple log files. There are some applications who do split the logging between an access log, an error log, a request log, a debug log, and then you have a whole bunch of logs. Which one do you direct to the standard output? Which one do you direct to the standard error? How do you collect it? Persistency. Do you need persistency? One of the great advantages of the cloud and the microservices world is the great support for a stateless application, where you don't save your state as part of the application. It will usually be saved in an external database or similar, but the idea here is to try and think twice before you require persistent storage, because persistency requires more resources and require you to better handle the life cycle of your application. What happens when your application terminates? How do you terminate? Do you catch a termination signal? When your application is running in the foreground, does a Control-C actually stop it gracefully, or does it crash it? What happens when you have a hung process? And how do you survive a restart? High availability. We are encouraged to use high availability as a new standard. Multiple instances of your service, which will improve durability, improve availability, will help you go through rolling upgrades, zero downtime upgrades. If any of the pieces of your Kubernetes cluster crash for any reason, and it will happen, then high availability or multiple instances of your service will give you that durability. A great resource to learn about and prepare your applications is the 12-factor app. This link is going to be made available after the conference, but go and read it. It's 12 key points in making your application ready for the cloud native and microservice era. Security. With your application, which is usually part of a wider scope, run a lot of other third-party libraries. You use third-party libraries. You want to know if other things are running inside your cluster which are not exactly up to your security policies. So try and understand. You have to have good visibility and good understanding of what's running inside your cluster. License compliance is something also very important. Open source licenses can sometimes be a liability. If you just go and pull in a third-party library into your sources without understanding the legal implication, then you're doing harm to your company. Now let's talk about Kubernetes. One of the most important things is putting limits on your applications. Many of the applications will just consume as much memory and as much CPU as they can. Sometimes it's because of a bug, sometimes it's by design. If you don't put the limits on the resources running inside your Kubernetes, then you could have a resource drainage. One of your applications just draining all of the resources. Up to recent versions of Java, Java wasn't aware of the resources that are given to it by the container because it was querying the kernel underneath. So a Java process running on a Kubernetes node would think that the whole 64 gigs of memory is available for them. So you'd limit it on the pod level, and you would limit it on the Java process with the XMS or the XMX. Newer versions of Java do understand and do respect the limits given to it by the container runtime, so it has improved dramatically. We've had similar issues with RabbitMQ and MongoDB, which also were not very comfortable running inside containers inside Kubernetes. So you have to understand, put the limits on your applications, but be careful. Knowing your limit sometimes, or putting your limits sometimes, encourage us to do a bit of a greedy over-provisioning. Oh, I'll just give it a very high limits because it will share the limits with the other applications. But what happens is if you have many applications running in your cluster which over-provision the cluster's capabilities, and then the load starts, Kubernetes will start killing your pods with not really understanding what happened. So be aware of that. That's something very important to take care of. The health probes, I've mentioned it before. One of the key or the nice features about the lifecycle of your application in Kubernetes is that Kubernetes allows you to check the readiness and the liveness of your application. If you write your application correctly, and you can probe it to see if it's running correctly, if it's ready to serve, and if it's properly alive. Without these probes, you might have a dead application or a stuck application inside a pod, unwilling to release. With the right probes in place, an auto-healing mechanism will be kicked in, and if your application hangs, it will be forced to restart by Kubernetes. And for complex checks, you can just write a script. There are three types of probes. One of them is an HTTP endpoint, like you want to see that your web page is providing you with an error code of less than 400. Execute a script. Everything that is 0 is considered to be okay. And there's also a TCP connection. You just want to see that you're able to open the port to the application running inside the pod. Multiple containers in the pod. You have cases where you would like to put multiple containers inside a single pod. Usually the best practice will be having a main application or a main service inside the pod, and then other pods as what we call sidecars. These sidecars provide services like log collection, like proxy, like maintenance. There's also the notion of init container. That's a container that will start running in the pod before the rest of the container starts. That can be very useful for setting up configuration, for testing requirements before the application actually starts. Your application's lifecycle is challenging, or managing the lifecycle is challenging. You have to remember that your application is usually made up of multiple resources. You have to understand that having all of the configuration put inside a YAML is great, but how do I differentiate between my local development environment, staging and production, with the same application configuration? What happens if I want to roll back to a previous version? All of these challenges were addressed by multiple solutions in the Kubernetes world. One of the most popular is Helm. Helm is the package manager for Kubernetes. We are big users of Helm. One of the Helm co-founders is actually working at JFrog today. And Helm can be seen as the RPM of Kubernetes. you define all of your resources and its configuration inside the Helm package. And with very easy configuration management, you can differentiate between the different environments. You use the same chart for dev, staging, and production. You would usually leave all the default configuration values ready for your local environment, for your laptop, for example, and differentiate between the staging and production with version controlled or any other configuration management controlled values for these environments. It also helps you improve the management of third-party dependencies. Let's say, for example, Artifactory Helm chart includes also a reference to the Postgres Helm chart as a dependency. So I don't need to manage the database configuration, the database application as part of mine. I just need to declare it as a dependency. Very useful, very comfortable, and very powerful. Several commands that can help you quite easily manage and understand what's going on with Helm. We use it for debugging all the time. All of the JFrog applications are also supplied as Helm charts. We use these Helm charts also to deploy them for our development and for our production. So we gain a lot of experience from using them and using them with Helm. The world of Helm charts is huge. Everyone's created a Helm chart for any application you can think of. All of the database tools, WordPress, blogs, and other applications are easily accessible. There's an official hub for the Helm charts, hub.helm.sh. You're more than welcome to see what they have there, and you can also contribute your own Helm charts very easily through a pull request because this is all open sourced. Visibility in Kubernetes. One of the challenging facts about Kubernetes, and once you start using it, some of your developers will get angry. They'll say, well, look, I just need an SSH into the server. No more SSH. Well, you could technically open a shell into a running container inside Kubernetes, but that's cumbersome, and that is an anti-pattern. The idea here is to give good visibility to everyone by using external tools for your monitoring and your logging. There are many managed solutions that provide out-of-the-box tooling for this. We use in our development and also in our production environment a combination of Prometheus and Grafana. If you're not familiar, go look it up. Prometheus Operator, you can install it with a Helm chart, of course. It just works. It deploys Prometheus and Grafana inside your cluster. It starts collecting all the metrics and starts showing it. It also has integration with external alert systems, which is very powerful. For logging, there are multiple ways to collect logs. Again, logging is done by agents collecting the Docker logs or any other combination of, if you remember, I've talked about multiple logs inside your application. So you can use different agents to also collect the logs from inside and then externalize them. We use a stack of Fluent, Elastic, and Kibana, or Filebit, Logstash, and Kibana, and Elasticsearch, and Kibana. This is an example of how one of my pipelines look. We have a pipeline that on a click of a button will deploy all of this different geographically located services. So one of our products, our recent products, the JFrog Enterprise Plus, is a collection of different applications that are meant for big companies to be able to spread their data centers and their artifacts across the world and distribute them. So with a click of a button, you get a system made up of 3 Artifactories running in US, India, and Australia, I think, 2 X-Rays, 2 Jenkinses, and 1 mission control. And that's a single click of a button, 10 minutes in Kubernetes using Helm charts. And this actually helped us dramatically improve the durability of the system across long-distance geographic locations. What do we do with Kubernetes and JFrog? Well, we use it for development, spinning up very easy, very quickly development environments, and we also use it for production. Some of our customers use it for their on-prem solutions with our Helm charts. Some of the customers using the managed X-Ray or Artifactory on cloud also get it running on Kubernetes without knowing it. And we also have official Helm Charts, which are open sourced. You're more than welcome to see them. The community is very, very powerful. If you have issues, look into the community for help. I've worked with a team developing the RabbitMQ Helm charts. I worked with a team developing the MongoDB. I just asked for help and got help. So it's just like having another team work for you without actually putting in the money. And then you give them some in return. And now getting to the real end. I'm actually going back to the things I've said before. Start small. Get your application ready before jumping into Kubernetes. That's very important. Security. Get control and knowledge of what's running inside your cluster. Put limits on everything running. Use the health probes. Visibility. Very, very important. Both monitoring and logging. And spread the word. Work with the community. Thank you very much.